All right, hi everyone. So let's get started on today's work. Today is working back from what we did yesterday or last time in class. We went and had a factor. Let's go take a look at that as a review. We had a factor of, let's say, x plus 2 and x minus 3. And we said what values would make this go to 0? What x values would make this go to 0? And it turns out to cancel out a x plus 2, if x was negative 2, right, that would cancel out to become a 0. So x was negative 2. And if x minus 3, we wanted this guy to go 0, plus 3 to both sides. X is equal to 3. So these are our two possibilities to make this go to 0. Right? So today we're going to work backwards from that. And I'm going to give you guys, we're going to start here today. And we're going to end up with x squared minus x minus 6 equals 0. So this is our goal. We're going to start here, and we're going to go right to our polynomial version of it. Okay, so here we go. So to work backwards, here's the basic idea. If I told you my x, my roots of the function, let me graph this out for you. Negative 1, 2, positive 1, 2, 3. Negative 2 and positive 3. If these are the roots of the function, and we said we had a positive 1 as a coefficient, the graph looks something like this. But what would the original function look like? We know it's going to be x squared, but what are all the bells and whistles that come along with that? So we're going to start off with our roots. We're going to write our factors first, and then we're going to multiply those out. So here we go. First step is, what are the factors? So if we know the roots are negative 2 and 3, there's actually a standard form for it. It's x minus a, that's a. Okay? So where a is this number, so if I put x minus negative 2, our factor is x plus 2. That is like the authentic way of doing it. Let me write it for the next factor, x minus a again, which is x minus 3. Hey, there's no negative to cancel out. It's just x minus 3. And that really takes us back to our original form up here. Now, another way of looking at it is, if we have a negative 2, if we said x equals to negative 2, the factored to cancel out with a negative 2 is a positive 2. You can just do that mental math. That's the super easiest way of doing it. If my factor was, if my root was 3, well, to cancel out a positive 3, we need a negative 3. That's the faster, kind of like more intuitive way of doing things. Okay, so just be aware we can go back and forth either of these cases, where we write x minus the number. That's like the basic rule. But if you want to just do it intuitively, hey, how do I cancel out negative 2? Well, I need a positive 2 to cancel out. How do I get rid of a positive 3? I need a negative 3 to cancel that out. Now our next step is to actually multiply these out. Now x plus 2 times x minus 3. We're going to multiply this using the distributive property. So distributive property. You guys hear a baby crying? I think that's my kid downstairs. But he's like 4. Oh, I know why. My wife is trying to put my son to take a nap, and he doesn't want to take a nap, so that's why he's crying. You can hear it, right? It's like a horror movie. I don't hear anything. What are you guys talking about? Okay, sorry. Darn it, this is being recorded on YouTube. Okay, so here we go. We're going to multiply x and x. So that's what we're going to do first. Multiply the x to everyone in the back. Then we're going to take turns. 2 is going to multiply everyone to the back. Right, so let's take our time. X times x is x squared. X times negative 3 is negative 3x. We're done with the first term. Let's go ahead and work on the second term. 2 times x is a positive 2x. And 2 times negative 3 is negative 6. Okay, so we can always have like terms in the middle. X squared minus x minus 6. I don't know how to respond to that. Someone just commented that my kid has strong lungs. Well, I hope they'll have a nice singing voice if they have strong lungs. But, alright. So, I need to keep talking so you guys don't hear the crying in the background. Alright. So, here's the idea. So, this is my function that represents the roots with roots x equals to negative 2 and 3. Now, just to prove that to you, because we have the ability to do so right now, if I go ahead and graph this out on Desmos here, x squared minus x minus 6. If we take a look here, the roots of this problem are over here positive 3 and negative 2. Yeah, that's a function that has these two roots. All right, believe it or not. Okay, and that's really just some algebra 2 stuff going on. So today's work is really us starting with the roots, then writing the factors, and then from the factors multiplying it out to get our large polynomial. Okay, let's work on another one. If I say x is equal to 3, 2, and negative 4, okay, a couple numbers here. So we're not going to do any fractions today. We're just going to do whole numbers just to practice this. Where our factors are going to be, and I'll write this as f of x. You can again also write this as y, right? So what cancels out positive 3? Well, negative 3 does. So 3 minus 3 is 0. That was a root. Yes, the final answer will be a function. X minus 2, if I plug in 2 here, 2 minus 2 is 0. That was a root. And negative 4, x plus 4, because a negative 4 plus 4 cancel out to become a positive 4. Yay, easy peasy. Now, which ones do you multiply first? You could go from left to right and multiply those two first. Or you could multiply the first one and the third one. Or you can multiply these two first. It's up to you. Whichever one you actually find that's easiest. If you want to just do this for the sake of doing it without having to worry about what's easiest, just go ahead and go from left to right. So let's go ahead and do the first two. Now, I'm going to give you guys a hint of how to multiply binomials quickly to save time. We could have done x times x, x times 2, 3 times x, 3 times 2. We could do that. That's perfectly fine. But I want you guys to be able to do this in your head to save time, because we all love saving time. So here is what we noticed from our last example. The front will always be the front. Easy. X and x is x squared. The back will always be the back. 2 positive 2 times negative 3 is negative 6. So if we take that right now, the front and front will be x squared. The back and back will be negative 3 and negative 2. Negative 3 and negative 2 give me a positive 6. So we just need that middle term. And if you notice, let's go back up here real quick. It would have been the negative x and a positive 2x. So here's one thing that you could do. You could just take those numbers and combine them. Negative 3 and 2, which was what we were going to write anyways, becomes a negative 1x. Let's try it over here. Negative 3 and negative 2 combine to become a negative 5x. And that's how you could save time to do that middle term. You just combine the inner and the outer, and that will give us negative 2x and a negative 3x, which we could save time by saying negative 2 and negative 3 combined to be negative 5. And that's our middle term. Just to practice this real quick on the side, if I write x plus 4, x minus 2. Okay, let's try this right now real quick. The front, well, of course, would be x, and x would be x squared. What would the back be? 4 times negative 2 is a negative 8. And what's the middle term? Just combine. That's going to be 4x and negative 2x is positive 2x to save time. Again, you could have wrote them all out. X squared x squared minus 2x plus 4x minus 8. And of course, these guys would have combined to become 2x anyways. Okay, so I'm trying to save you guys some time. And that's the cool thing about binomials. We can always save time that way. All right, so our next term here, our next step is that we have to multiply this trinomial, by a binomial. Okay, so that's going to give us a lot of terms. And oh, there's the only thing you remember algebra 2. They're great. Yeah, the easy part. So we can take our classic step by just multiplying 1 by everyone in the back, then 2 by everyone in the back, then 3 by everyone in the back. We could do that, okay? That is our perfectly fine way. And let's go ahead and do that because it is not a hard thing to do. We just have to take our time through it. X first. X times everyone in the back will be x squared plus 4x, sorry, x cubed, I'm sorry, my mistake. X cubed plus 4x squared. I'm done with my first term. Move on to 5. Remember this is negative 5. Negative 5 times x is going to be a negative 5x squared minus 20x. Okay, done. Move on. Next term. Do 6 plus 6x plus 24. Okay, we're multiplying the 6 now. And that's perfectly fine. Now the only thing now you have to do is that we have to look for like terms. Looking for like terms is not hard, but maybe there's a faster way. But let's go ahead and do it since it's pretty easy. In this case, these like terms are actually right next to each other in this version of it. Okay, so we can combine those. X cubed minus x squared, because negative 5 plus 4 is negative 1. Negative 20 plus 6 is negative 14 and 24. Okay. So no matter what method you use here, when you're multiplying large polynomials by each other, you're still going to find the same amount of work. The organization might help you save time, but no matter what, you're still doing the same amount of work. Like, the idea is I have 3 terms times 2 terms. I should end up with 6 terms. 3 times 2 is 6. So I end up with a 1, 2, 3, 4, 5, 6. No matter what, you're going to end up with those combinations of each other. Now, I'm going to rewrite this problem slightly differently. If I wrote x plus 4 times x squared minus 5x plus 6, this is a different method slightly just when it comes to organizing these problems. And as the problems get a little larger, you might want to find different ways of organizing the problems to make your life a little bit easier. Instead of looking at, let's say you have 20 different values and you have to start combining them, you could miss stuff. So here's another way. If I multiply x, that's not hard at all. X cubed minus 5x squared plus 6x. Now my next move is to multiply everyone by 4. But look how I'm going to do it. I'm going to write this on not the same line here. I'm going to write it underneath. And this is probably something you learned in Algebra 2. So when I do this, I'm going to combine my like terms rate. Plus 4x squared minus 20x plus 24. If you take a look here, when I write it, all the like terms are already lined up. And they're right next to each other. So it's easier to find than me having to look throughout the problem. That's x cubed. Negative 5 plus 4 is negative 1x squared. 6 minus 20 is negative 14x. And 24. We end up with the same answer. And really, we did exactly the same steps. But organizing it a little bit differently might help us from looking for like terms. Okay, so it's important for us to be able to rewrite this around. What steps? These are all the steps I teach in Algebra 2. I'm not doing anything funny. Okay, so let's move on to, we went from 2 roots to 3 roots, and now we're going to do one more step. We're going to do, actually we're going to do another one with 3 roots, but this one's going to be an interesting one. If I say x is equal to 5, let's say 3 and 0. Okay, 5, 3, and 0. So we're going to write x minus 5, because 5 minus 5, right? 5 minus 5 is our 0. That's a root. X minus 3, because 3 minus 3 is a 0. And the last one is this. If I wrote x minus 0, folks, just a reminder, what is x minus 0? Isn't that just x? So what I would do instead is I would actually say this is x, x minus 5, and x minus 3. And this will actually save me time. I don't have to write the 0. We can just write the x in front. And that's actually going to be our last step in multiplying, because we're going to multiply these easy guys first. So here we go. If I multiply these guys first, it'll be x in the front. And when we said we can multiply binomials easy. X and x become x squared. That's easy. Negative 5, negative 3. That's going to multiply to become negative, so positive 15. That's our last number. Front, front, back, back. Now what's the middle number? Negative 5 and negative 3 is negative 8x. And now, since one of them was just an x, it's actually really easy. Next step is just add an x to every exponent. X cubed minus 8x squared plus 15x. So a couple hints. If we have one of our roots being 0, it's really just going to be adding an x at the very end. So leave that 1x last. Right. Now let's do one more problem. And this is the one that's going to have 4 roots, okay? So we'll say -2, -1, 1, and 3, okay? Pick a couple of these numbers here. And we're going to just do this straight. No special tricks. X plus 2, X plus 1, X minus 1, and X minus 3. Double check that. That would be 0. This would be 0. This would be 0. This would be 0. -2 plus 2, -1 plus 1, 1 minus 1, and 3 minus 3, okay? And this is our function. Now let's go ahead and multiply these quickly, yet sanely, okay, carefully. Here we go. The first two are pretty easy. That's x squared plus 2 in the back, and the middle term will be 2 plus 1 is 3x. Make sure you copy all the steps. We're going to multiply this by x minus 1 next. Now, I could write this in the front like I did before, but know what? I'm lazy, and I don't like recopying things that I don't have to. So what I'm going to do here is I'm just going to leave it, which is perfectly fine. But I'm going to just change the order as I write it out, okay? What I mean is, I'm going to multiply everyone by x first, going this way, and then by -1. So let's do it first. If I multiply everyone by x, easy peasy, that's going to be x cubed plus 3x squared plus 2x. All right? Then I'm going to multiply this everyone by -1. And when I multiply everyone by -1, take a look here. That is negative x squared, which I have a like term to already. So please line those up. Minus 3x lined up. Minus 2 all lined up. Here we go. Rewriting this as x cubed plus 2x squared minus x minus 2. And we're going to multiply this guy by x minus 3. So our x cubed became x cubed. So yeah, x squared became x cubed. So x squared became x cubed. And now we have one more step to do. And you might say, Mr. Cole, there's so much writing. You know what? If you know your basic multiplication tables, not that much time. The more we complain, the slower we do this. So we're going to multiply everyone by x and everyone by 3. So if you take a look, I'm not going to rewrite this in the front. I'm just going to take it as it is. Here we go, multiplying it by x, x to the 4th, plus 2x to the 3rd, minus x squared, minus 2x. Now we're going to multiply everyone by -3. And I see I'm going to have like terms, so please take a look here. I'm going to write -3 times x cubed is -3x squared on the second line. And my terms are going to be, like terms will be on top of each other. Minus 6, -3 times 2 is 6x squared. -3 times -1 is positive 3x. And -3 times -2 is a positive 6. So all the terms are right on top of each other, so I don't waste any time with this. That's it. And I'm going to actually graph this so that you can believe that the roots of -2, -1, 1, and 3 are actually hidden in this graph. And that'll be the last thing we do here. Kind of weird, I can't zoom in on that. That's not awkward. So we're going to say x to the 4th minus x cubed minus 7x squared, and then plus x plus 6. All right, just double check if I copied that correctly. That looks about right. And if you take a look here, do not be amazed too much. Hold in your excitement, but our roots are -2, -1, 1, oops, -2, -1, 1, and 3, which is what we said our roots should have been. Okay, and that's it.